welcome to Community Conversations. My name is Liz from the Dfinity Foundation. This is an opportunity for you, the community, to hear from contributors within the internet computer ecosystem, as well as ask them questions live. So virtual people parties coordinated by the internet computer establish the personhood of otherwise pseudonymous identities. In a virtual people party, a small group of users validate each other's personhood in a process that is fast, easy, and anonymous. Today, we have senior researcher Bjorn Tachman here to talk about people parties. Feel free to take it away, Bjorn.
Thank you, Liz. So let me share my slides. Okay. As Liz mentioned, we're going to discuss about people parties today, which is something that we propose to implement on the internet computer. And there should be a motion proposal for this going out later today. So if you find that what you see here or a variant of that, there's also a forum thread dedicated to this topic where we discuss potential changes, potential modifications. If you think a variant of this should actually be deployed on the internet computer, then go and vote for that motion proposal. If you think that we shouldn't be doing this, vote against it. So just watch your NNS step or whatever, and IC dashboard, whatever you use to observe the proposals, and watch out for the motion proposal on people parties. So what's the scope of a people party? The entire goal is for the internet computer, or for dApps running on the internet computer, in particular the governance system itself, to be able to tell bots or computers from humans. And in theory, this problem has been described like ages ago in the last century. It's actually the Turing problem. How do you distinguish a human from a computer? In practice, you most likely see this pretty often as a CAPTCHA, which is used in the traditional web to determine whether you're a bot and or you're a user that tries to actually log into the system. And that's usually used to protect some kind of valuable resources. Resources can be pretty abstract, can be computational resources, can be valuable data that may be otherwise crawled by bots and that the provider of the data wants to protect. Now, CAPTCHAs, they kind of work in practice. I guess you've been solving or at least one in the last 1 or 2 days anyway, if you logged into one of the major websites. But they have some issues. I mean, first of all, they're not really precise. If you know what you target, like if you're an attacker that tries to target a specific CAPTCHA, there's a good chance that you can actually solve a bit of it. We have to increase difficulty to react to that and so forth. That again makes it more difficult for users. But there's, like, if we think about using CAPTCHAs on the internet computer for similar purposes, there's a more fundamental reason, and that more fundamental problem, and that is that in order for CAPTCHA to work, you need to keep some kind of a secret, right? You need to, as this server in the traditional web, you need to generate the CAPTCHA, and the CAPTCHA has a solution. That solution should be kind of random and kind of secret. Then you send the CAPTCHA to the user, or what you expect to be the user on the other end. The user solves it, and you compare whatever the user sends you to that challenge that you stored. And now this is a fundamental problem in blockchain systems, because if you're running a dApp, you're effectively running a smart contract doing that. And that smart contract is hosted on different nodes. Those nodes may be malicious. So it's kind of a long shot to really believe that whatever you store there will remain secret. If there's one malicious node provider, they could look into the state of the smart contract and leak that. So even there's a fundamental mismatch. Probably in practice, you could still make it work, and probably in most of the cases it will work, but it's not the greatest mechanism ever, and it does have some discrepancy or some disadvantages. But if we move from like the traditional web more to the blockchain ecospace, there's something more we want. We want more than just validating that whoever we're interacting with is a human or a computer. We would actually want to validate that it's a unique human, right? So that everyone who participates in whatever check we do can participate only once. And in some sense, if we had that, there would be kind of the dream decentralization. At least it's the kind of the purest or the most democratic form of decentralization, where we give every human one vote in such a system. Unfortunately, that's pretty hard to achieve in practice. And I think that's the main reason why most blockchains have some different mechanisms like proof of work, where you burn energy, and burning energy is expensive. And so if one person burns a lot of energy or expends a lot on hardware, that somehow bounds that power of that person. Similar proof of stake, it's like you associate the voting power by the stake that any person has in the ecosystem, and thereby richer people get more power. But also, if the stake is somewhat distributed, it's not a centralized system. But it kind of would be nice to get a better sense of decentralization there. So to give more power to people that don't have these huge amounts of tokens in a proof of stake system. And so what we want to achieve with people parties is getting a scalable proof of personhood on the internet computer. And that has three main goals. The first one is, in the long term, it may help us to actually drive toward the democratization of the internet computer. Right now, our governance system is purely based on stake. So if you stake, if you lock more ICPs in a neuron, that gives you more voting power, which means you can influence decisions with more certainty, and you can also gain more voting rewards. So in a sense, it gives a lot more power and a lot more benefits to those who already have a lot of tokens. And it would be great if we could move that to the other direction, and if we could give more power to individual people that maybe don't have these huge financial resources. And the second point is very much related. It's democratization of open internet services. So by open internet services, I refer to dApps running on the internet computer that themselves are controlled in a decentralized way. So those dApps can have a governance system, just like the network nervous system governs the internet computer. These dApps can have a governance system that governs these dApps. So the governance system would decide on how the dApp would be upgraded. It would decide on parameters of the dApp, whatever is important in that particular context. And users could hold shares of these dApps, of course, or of the tokens that are related to those dApps, to those open internet services. And so this is a feature that we're also planning to launch next year, early next year. And kind of doing the people parties as a first step gives us a notion of better decentralization that we can make use of when we later launch the kind of default open internet service architecture. And the third part is it kind of gives a supercharged capture to applications. I mean, to dApps running on the internet computer, be it like social network dApps or the open chat communication dApp that we have. Right now, they do face issues with bots registering for the dApp. And actually, the canisters running on the internet computer, they have less weapons in a sense than, or less armor than traditional web services have. For instance, if you were running a traditional web service, you could be observing IP addresses that you get the requests from. You could be trying to get more information about the browsers to see whether you can notice certain patterns. So that's all the stuff you can do in the traditional web. We don't give that much information to canisters, or even if we were to do this, it wouldn't be really trustworthy because it would only provide the view of whatever node has the connection to the browser that loads the page. And that node, if it's acting maliciously, it could replace data such as IP addresses or things related to the browser information. So the canisters on the internet computer actually have a harder time protecting from bots than web services running on the traditional web. And we feel that this is a problem that has also been mentioned by the community. And we want to see whether people parties can be one method, maybe not the only one, but maybe one helpful method to provide those dApps with armor against bots that try to maliciously change the contents, for example, of a social network. Now, to describe what the people parties look like in our vision, I tried to kind of map this into a timeline where we start from the left and we go to the right. And I tried to describe the journey of a single user. So the first thing that would happen is that for a particular instance of a party, we open the registration phase. And the registration phase means every user can come there, can log into the people party canister and see their profile page. And then they will have to send one ICP. I'll give a bit more detail about that later, to an account that is they have to deposit that to an account that is held by the people party canister itself. So it's kind of kept in custody for the time the user uses the people party. So they want to participate in this process. And a few days ahead of the published date of, or time and date of that people party, the user would have to commit to a certain location that they will be at during the time of the party. The party itself will take like 5 minutes. It's one specific point in time, and the user has to choose that place. And here the rough idea is that we don't want the user to lose all their anonymity, right? We don't want, say, a video conference where people show their faces and they're recognizable by other people on that call. We want this to be kind of anonymous. So what we prove, instead of seeing a human and seeing a human acting, we see the effects of a human acting. So we will use, it will be a camera, like a video conference, but what we want to prove is that the user is actually at a certain location. And the thinking here is, any user can only be at one location at one point in time. So for that people party, you commit to one location. And if verifiers check that you are at that location, then hopefully no other verifiers will successfully check that you are at a different location, right? So you should only be at one location, and validating that is actually the core idea of the people party. The location must be in the correct time zone. So we will have initially probably 3 instances, one for Asia, one for Europe, one for the US. Maybe we'll become more fine-grained in the future, but we think 3 is kind of a good trade-off to start with. So the location that you commit to must be in that particular time zone that you are that is associated to that party. And it must be at a minimum distance from other participants. And the reason here, again, is that you should not be able to prove that you're in 2 locations, which would be very easy if those locations would just be like 10 feet apart. So instead, we will have some minimum distance, could be maybe a few hundred meters or so, so that you that every participant, or that it's impossible for one participant to successfully prove 2 locations during the same people party. So after you've registered and after you've committed to that location, at some point the registration phase will close and we'll start the actual party phase. So the party phase will have a short duration, maybe about 1 minute or 2, or whatever we feel is reasonable, could also be 5, where people can be joining. So after they have registered and now they can be joining that call, and they will first sit kind of in a waiting room and hopefully read instructions. And then during that time, the people party system, the canister backend, will generate a random assignment of groups. So up to that point, no one knows which other users will be assigned to that same group. It's unpredictable. You only really learn this immediately before the party and the video call starts. In that video call, what's going to happen is that we'll cycle through the users one by one. And by now, we mostly decided on having 4 users in every one of those groups. That has technical reasons. If you're interested, I'll be happy to tell you a bit more about it. We first thought about using 6. That's also probably in the material we have in the forum. And as I said, we'll cycle through those users one by one. And in each phase, there's one user that acts as the prover. So that user that proves their location. And that user will take a video of their surroundings. So they prove their location by showing to the other users that they are at a particular place. And what we are going to do is that in the lower half of the screen, we're going to show Google Street View image of that place. So everyone else has a realistic chance to actually validate that the person is at that place they claim to be. And during this phase, the other users should also put challenges or ask challenges to the prover, which could be like, move your camera to the right, please move your camera and film the sky, walk to the yellow car. Something that is easy for that user to verifiably do while they're filming with a camera, and that helps the other users to validate the personhood of who holds the camera, as well as the location that this person is in. The other group members, the verifiers, can then vote to either approve or deny. And then, as I said, we cycle through all those 4 members. Hopefully if they're real humans, hopefully they will get approved. And if you get more than 2 accept votes, and if you participated, so if you also voted on other users, you will count as verified as a person. After all those parties are over, we're then having the canister do a tally phase where we, as I said, we count those votes and see which users should be counted as validated persons. And in the phase on the right-hand side, so that's a phase that is ongoing from the first party onward, basically, the people party canister will then provide information to other parts of the internet computer ecosystem. It will provide boosting for neurons, and it will provide a validation service for other dApps running on the internet computer. I'll have a bit more about that on the next slide. So this is kind of the component architecture that we envision. The people party canister is a standalone canister. It's not tightly integrated with any other mechanism of the internet computer. It's just a canister that runs a dApp, and that dApp happens to be the people parties. The people party canister kind of interacts with internet identity. Internet identity will be one way of authenticating toward the people party canister. It shouldn't be a requirement. Depending on how fast we advance, it may be a de facto requirement initially, but we really want this to be open. We really want this to support any other means, say plug wallet or whatever other means of authentication come up on the internet computer to support this. So we don't want to make internet identity an actual requirement for users to use the people party canister. The people party canister will then, that's what I mentioned on the previous slide, boost neurons in the governance system. And doing this has 2 reasons. So how that works, first of all, how that works is, as a user, you will be able to designate, as a person that is validated, you will be able to designate 1 neuron in the people party canister that will be boosted. Can be your neuron, can be someone else's neuron, doesn't really matter. We expect that most users that get validated would like to boost their own neuron, or maybe one of the family members' neurons or so forth. But that's fine. And what happens is that neuron will get a virtual bump for some restricted amount of time. Numbers we're suggesting could be like 20, 24 something ICPs for a duration of 6 months. So once you're validated, you designate your neuron, and your neuron will behave as if it had 24 additional ICPs, both in terms of voting power and in terms of reward. And that's kind of like, it's a win-win situation in a sense, boosting the neurons, which is, on the one hand, it does improve the decentralization, not by a whole lot yet, right? It's only 24 ICP if you compare it to the huge neurons, is not a huge deal. But if you participate in people parties over and over again, you should receive bigger rewards. And so at some point, it should matter if we have sufficiently many people who get sufficiently often validated, they actually get a significant share of the voting power. And on the other hand, of course, so that helps democratization. But on the other hand, it also gains them rewards. Like if you have a neuron that has more voting power, you gain more rewards, you get a payout. So effectively, you do get a dividend for being validated as a person on the internet computer. And on the lower hand side, on the lower side of the slide, there is interaction with any dApp that that runs on the internet computer for the purpose of validating that users of that dApp, whether or not they are validated persons. And whatever the dApp wants to do with it, I mean, it could be in the launch of an open internet service, you could give some free governance tokens to any validated person, for example, if you want to improve decentralization. If you think about social networks, you could give elevated privileges for voting posts up or down to validated persons compared to those that are not validated and could potentially be bots. So this depends a lot on the application. The high-level idea here, we're just writing the first spec for that protocol. The high-level idea is we want to keep it simple. It will probably introduce a slight linkability between user accounts on different services if the services want to use it. So it does weaken the unlinkability that we get from internet identity, for example, by a bit. But we feel it's a good starting point. We can improve more and implement more complicated protocols later. We want to start with something simple that is also easy to implement for the dApp developers. And we think that this is a good trade-off to give up a bit of the unlinkability toward having it actually easy to implement and easy to be used by various dApps. And the last point where we need to interact with that canister is, of course, the mobile phones. We expect that almost all users will use a mobile phone to connect to the people party. Also, I didn't explicitly mention that before. We need users to commit to a location that is actually available in Google Street View. So you wouldn't be able to prove that you're in your own home, for example. You should choose a location that other people can recognize. Could be a street corner, some very distinct location in the city, maybe a train station or a monument, something that really helps users validate that you're at that location. So we expect many users using a mobile phone. That's why I've just been drawing mobile phones. We don't really depend on them being mobile phones. And those mobile phones, they communicate with that canister for everything that is kind of meta information. So they register, they join the call, they put the votes in at the people party canister. But the communication for the video calls, that happens purely between those mobile phones. At least logically, it's a direct connection between mobile phones. So if I am the prover and you are my verifiers, then my phone will actually have point-to-point connections to each of your phones and send them through an end-to-end encrypted channel to each of your, send my video through an end-to-end encrypted channel to each of your phones. Now, a bit more details about the components and the mechanisms. The people party, or the personhood canister, we call it personhood canister, and it does people parties, exists on a separate dedicated system subnet. So the fact that it's a system subnet means it's kind of part of the, more or less part of the Internet Computer Governance System, and it does not pay cycles. That's kind of important for decentralization, because we don't want this feature, or we want this feature to be as little reliance on any particular party as we can make do with. So that's why we decided to put it on a system subnet where we don't have to fund it with cycles, where it's paid by the overall IC infrastructure. It is controlled by the network nervous system. So it will be installed, it will be upgraded through the same type of proposal that you see when we propose upgrades to internet identity or to the NNS dApp. So those will look very much the same. We are also using determinate or reproducible builds in a very similar way there. And as I said, it manages the entire meta flow. It manages the parties themselves, the registration, the joining, and the voting, and then tallying of that phase. Now, one word about deposit of ICP, because that's obviously a nuisance for the users, right? Who likes to put some ICP there if that's not necessary. The reason why we think that it will be necessary is, again, denial of service attacks against the canister. If we had no means of restricting a user for to register on the people party canister, it's very easy to create thousands of accounts for bots. So we think that putting one ICP as a deposit that you can get back later, so it's really just a deposit, you can withdraw it after the party is over. This will make a bot attack, first of all, more expensive, but also more risky. Because if there's a large scale bot attack, who knows, maybe the governance system of the NNS decides to block withdrawal for now or something, right? So that's very little, or that's manageable risk for an individual, but it's big risk if you do a large scale bot attack on this. But again, this is up to the governance system. It's a decentralized system. So this is something that the community, the ICP community in the end has to decide how that canister should behave with respect to everything in its code. And the user will send the ICP to a dedicated sub-account. So this is a mechanism that we've also been using in other canisters, such as the governance canister or the NNS DApp canister. It's a sub-account that is controlled by the canister, but it's a unique sub-account for each user. That simplifies management quite a bit. So if you, now that we will hopefully have ICP on canisters soon, if you think about supporting users having ICP somehow managed by your canister, this is a scheme that you may want to have a look at and that you may want to use, because it needs much less interaction between your application canister and the ledger canister to validate that a user has made a certain transaction. And it's still safe because every sub-account is actually controlled by that canister, or it's at least, it's transparent. If the canister is controlled through a governance system, everyone can check the code of the canister and see what the withdrawal, in this particular case, what the withdrawal code looks like. And just at the bottom, this is, I made the slides before we actually made the proposal for the canisters hold ICP feature. This, of course, heavily depends on canisters so hold ICP. So I'm crossing my fingers that we'll have that feature soon, because people parties actually need that feature. For the video calls, there's two things I want to point out. In terms of the communication between the phones is not always as direct as I made that look on my previous slide. WebRTC is logically point-to-point, or it's point-to-point in security sense, in the way that there is a end-to-end encrypted connection between the phones. But there's two ways in which it's not quite point-to-point. And the first one is we need some way of to set up the session, right? Initially, you have two devices. You want them to share a cryptographic key, so you can do end-to-end encryption of that transfer. How do you get that key exchange in the beginning? And so that is in WebRTC, that works through a protocol called SDP, Session Description Protocol. And WebRTC itself doesn't really specify how you should get these SDP packets from one browser to the other. It just says one browser sends it, and then the other one should be receiving it. And the right way to do it for the people party would be to just exchange it via the canister, right? You can send an authenticated update call to the canister, and then other users can retrieve your SDP messages from the canister. The canister checked the authenticity of your ingress message, and the other users can depend on the integrity of the canister when they retrieve the SDP messages dedicated for them. Now, we don't do this exactly for the reason that it would take quite a bit of time, because it's a lot of update calls that would have to happen in sequence, and that would cause a pretty big delay when setting up a call. So what we do instead is that we exchange cryptographic keys, we exchange cryptographic signature keys through that mechanism, through the canister. And then we use those keys to authenticate messages that we send out of band through a centralized helper service. So we do get the security guarantees, but we actually use a slightly different way of communicating the messages. The second one is net traversal. Like if you're using a cell phone, every network provider will have a very different setup in how they give you IP addresses and so forth. But what they all have in common is that they won't really work for point-to-point connections. There's some that do, but most don't. And so what we need to do instead is that we need to relay that traffic as well. So there's going to be another, again, centralized helper service that does not need to be relied on for security purposes because all the traffic passing through it is end-to-end encrypted, but that is actually needed. And that's a turn server. So you may have seen that before. It's a pretty standard protocol, basically allowing users to send all their traffic, send and receive all their traffic through some server on the internet. So the planning here is as follows. We have the people party canister interacting with the phones. That's just standard canister calls as we always do them on the computer. And we have the phones communicate also with these centralized helper services, but not relying on these services for any type of security property. It's really just enabling the communication that we need so we can actually have virtual point-to-point connections between the mobile phones. So that's as far as I have prepared for today. I expect that there will likely be a good number of questions. Yeah, so please ask me any question that comes up and in your mind, and then let's vote on the motion proposal once it's out on the network nervous system.
Cool. Thank you so much, Bjorn, for that. So we have a question here. If a user has hardware issues, do they have multiple chances to participate with a single registration? Does the registration ICP get burned if you fail multiple times?
So the people party itself will only be a few minutes. So what you can do is you can reload. We try to ensure that whatever we build in the front end will be resilient to reloads. So the front end should be reconstructing the same state, and you can try to build up the same connections as well. But if you have a longer lasting issue, maybe your sub provider is down, maybe your battery dies, then your bait is basically out of luck for that particular instance of the people party. For now, we don't plan to slash any part of that deposit, at least for the first instance, but this is a decision that in the end the community has to make. The reason I am against slashing in the first instance is that, I mean, we will test this as best we can, but it's going to be used in a different scale than we'll be testing before. So it's going to be used in different locations with different cell phone providers that we could have checked before. So I think in the first instance, putting people at risk for actually losing ICP, I think it would not be prudent to do that. So I think at least initially we shouldn't be doing this. Maybe in the long term, the ICP community figures out that this is a better mechanism to actually try to thwart bots because they actually have a bigger risk of losing actual ICP. I don't know. It's something that the community should also have an opinion on, and then we'll see how we move on that long term.
Okay, excellent. So next question, does the availability of Google Street View or Maps essentially tie the OIS to a centralized service? Secondarily, is proof of humanity only available to those in a place that Street View has been? For example, are developing countries exempt from this?
Yeah, these are painful questions, both of them. And the answer to the first one is we would love to not depend on that. But it's actually hard to say, do this without that data right now. We wouldn't not necessarily have to depend on exactly one provider. There's also other providers that have slightly less data. But we can't really see making the validation work without other people seeing pictures of the environment. And we may be able to solve that better in the future, or to give a restricted option in the sense of at least you see open street maps and you can try to see whether the streets look the same and so forth. This is up for discussion, in my opinion, whether we want to build on that and take the risk that part of our service is built on a centralized service, or whether we want to not do that. And the second part is, Yeah, initially that's unfortunately the case, and we should be improving on that. And there have been similar questions in the forum. For example, people with disabilities, what's up with them, right? If you're deaf, you may not be able to participate in the same sense, at least not in the same speed that other people can. And so these are pressing issues which we have to resolve. So the first people party we run will not be as inclusive as it should become in the long term. But we see this as one step along a path where we need to improve over time and being more inclusive in various dimensions.
Cool, thank you. So has there been any engineering thought put into an OIS that would take the place of the stun turn setup to achieve 100% ICOIS, maybe on a different L1 or L2?
What do you mean by OIS?
Andrew, can you clarify that in the chat? Just want to make sure we're answering your question. In the meantime, we can move on to a different question. So,
open internet service.
Yeah.
Well, the problem here is we're really facing problems at lower protocol layers. So right now we wouldn't be able to real-time stream all that data, say, through the inner computer. It would need to go through update calls, and there is a delay, and so it's just, and it would of course be a lot of data. So it's right now, I think that would not be possible to do this via the inner computer if we want those parties to, first of all, be interactive, and second, scale in the terms of number of participants. So doing this point to point would be ideal, right? Because central services never scale as well as saying things peer to peer. But unfortunately, yeah, we'll also have to see how things develop. I mean, at least in my case, I don't even get an IPv6 address on my phone from my SAP provider. I think, I mean, that's like ridiculous, right? 25 years after or 20 some years after IPv6 being introduced.
Awesome. Thank you, Bjorn. So next question, what stops a person from joining different people parties at different times to verify personhood with a new neuron each time?
Well, so you can do that with a new neuron each time. If you on one day, you should be able to participate only one, or maybe in extreme cases where you just at the border of two possible parties, maybe two parties. But there will be a frequent, maybe every 2 weeks, there will be one such day with multiple such verification parties. And so you can participate in everyone. You should participate in everyone. And whether you do this with the same neuron or with a different neuron, it doesn't really matter so much. I mean, you're validated as a person, you're validated multiple times, you get rewards. If you get them in the same or in different neurons, as long as you get the same or less than you would get in one neuron and not more, it's not actually giving you any advantage.
Thank you, Bjorn. Next question, are you going to publish all of this as part of a Medium blog post?
We should, yes. We are working on this. It's just additional work that we have to do next to speccing and implementing everything, but that's totally planned, publishing that as a blog post.
Excellent. So when do you expect the proposal to be open for voting, and what is the timeline for it to be implemented?
So it should be open later today. I have to coordinate what exact time that means, but I expect this to be in the next few hours. It should be open, and then it will be open for voting for at least 24 hours. That's the wait for quiet mechanism that we now have. It's 24 to 48 hours is the voting period. And for implementation, we would actually hope that we can get a first version of that even in December. Whether that's earlier or later depends a bit on how many technical roadblocks we hit. We did hit quite a bunch when we tried to make the peer-to-peer connections between the phones working. So that delayed our initial optimistic plan a bit. But yeah, we're still optimistic that we can make it this year for the first instance.
Cool. Next question, will people parties be at locations across a large country, or do you expect people to travel? I think people mean, are there going to be different locations for them?
Yeah, I mean, as I said, we'll probably initially go, or we will probably suggest to initially go with 3 slots for one day, one being Asia, one being Europe, one being US. And you can participate in any location within a certain longitude range. So whether you're in Paris or in London, doesn't matter, you'll be in the same group of people from which we then choose the groups of 4. Whether you're in LA or New York or Brazil, doesn't matter. You'll be put in the same set of people that we draw from.
Cool. All right. So the last question for today: would a secondary non-video assessment option, like user create a puzzle, see ID in a chain, be possible to implement in the same people party OIS in future updates? Maybe like the non-video user answers questions while the video users are validating.
I think it's something that we should discuss within the community, whether we need to evolve the format, whether we want to have several formats in addition. I mean, I think it's something that we have to see what works, what then also related to the previous question, how we can be more exclusive toward people that cannot attend if we just run people parties in the exact same way that we do now. I also think that we may want to use information that we have from previous people parties, maybe in getting a better distribution of validators, because we may have people that we already have high trust in being real people, and they could have more power in the voting process in future people parties. So I think that's not explicitly planned, but all these things we should try what makes the mechanism most successful against bots, and of course most inclusive and simple and easy and fun.
Okay, excellent. So we have come to the end of our questions for today. So big shout out to Bjorn for such a thoughtful overview of people parties. Thank you for everyone in the community for tuning in and for all of your great questions as well. And looking forward to seeing you at a future community conversation. Bye, everyone.
Thank you.